Hello everyone, my name is Sophia, and in this video you will see how to go from an idea to a fully working prototype using Projexlight AI. You will learn how to generate a complete prototype, export it to your local environment, run the autonomous code generation, and then see how tests and quality checks run automatically end-to-end. By the end, you will understand how Projexlight can generate clean, standards-compliant code, spin up your development environment with Docker, and validate your APIs with automated tests and reports. Step 1. Create a new project and prototype. To start, create a new project in Projexlight. Click the New Project button, choose Quick Prototype, and give your project a name, for example, Taxi. Add a short description of what the application should do, then click Create Project to continue. For a full production project, you could also capture detailed requirements in the Requirements section, but for this prototype demo that is not necessary. Instead, go directly to Code Generation and select Quick Prototype. On this screen, Projexlight automatically reads your project description and refines it into a structured generation plan. If needed, you can change the underlying LLM model, but here the default GPT-4 based model is sufficient, so continue with that. Step 2. Generate the prototype plan. Now you can see the generated content for the prototype, epics, features, scenarios, and tasks extracted from your description. Click Generate Prototype Code, or the equivalent button in your UI, to accept the plan. Next, Projexlight generates the underlying schema. Review the proposed schema, then click Continue to confirm. After that, select the records or entities you want to include and move forward. At this point, Projexlight begins generating a large amount of project scaffolding for you, so it may take a couple of minutes to complete. It is generating epics, features, scenarios, tasks, and database tables in one pass. Once generation is complete, you will see a summary such as several epics, multiple features, dozens of scenarios and tasks, and the corresponding tables all created for you. This is your full prototype blueprint, ready to export. Step 3. Export the CLI package and unpack in VS Code. Now click the Download or Export button to export the CLI package from Projexlight. This gives you a zip file that contains everything needed to run autonomous code generation from your local CLI. After the file downloads, open your file system and unzip it into your working folder, for example into a test directory inside your VS Code workspace. Open that folder in VS Code. Inside, you will see a product folder along with an instruction file or README that explains how to run the CLI. Delete any temporary instruction stub if required, and keep the main README that describes the commands. Open the README file and copy the CLI command that starts the Projexlight product agent. Then paste this command into your terminal window in VS Code and run it. Step 4. Start autonomous code generation in Docker environment. As soon as you run the CLI command, Projexlight starts reading the generation plan and begins the autonomous code generation process. You can see in the terminal that it is scanning files, understanding the tasks, and orchestrating the steps without requiring additional prompts from you. While the code generation is running, open another terminal window or your Docker dashboard and start the Docker environment defined by the project. Select the Docker configuration for this prototype and start the container. You will see the containers being created and started. The database container also comes up, and the necessary tables are created according to the schema defined earlier. At this point, your development environment is fully set up, database is ready, backend services are running, and the MCP, the Projexlight monitoring and compliance process, is active. Step 5. Let Projexlight generate and validate the code back in the terminal. You can watch Projexlight continue to generate code. Most of the time there is no need to type anything. The CLI reads the generation plan, understands all the tasks, and proceeds autonomously. Occasionally it may ask for a simple yes, no confirmation, which you can provide. As it works, Projexlight generates code for each task, validates the changes, and prepares commits automatically. You will see it staging files and making Git commits without you having to manually manage each step. Inside the Projexlight UI, you can now inspect what has been generated so far. You will see all the epics, features, scenarios, and tasks created earlier, and as code is generated, the associated artifacts are updated. There is no spaghetti code here. Projexlight follows the structured generation plan and your coding standards, so you get clean, consistent source code, not a mess of ad hoc scripts. Step 6. Enforce coding standards with MCP and company guidelines. Now open the settings section in Projexlight and look at the coding standards configuration. Here you can upload your own coding standards document, such as a markdown file describing your company's best practices, naming conventions, and architectural rules. Once this standard is uploaded, the MCP process uses it during every commit. When the CLI makes a commit, MCP automatically scans the changed files for coding standard violations, duplicate code, and other issues. You can see in the MCP logs that it is scanning all generated files, applying your rules, and reporting any violations. This means that even though AI is generating a large amount of code very quickly, it still conforms to the standards your organization expects. Step 7. Generate tests and run them in Docker along with the application code. Projexlight also generates test data and API tests. Navigate to the test folder in your project and open the API test directory. You will see test definitions and sample data for the major APIs created by the prototype. In the Docker container logs, you can see the compliance summary, how many files were scanned, and the overall compliance percentage. After that, the system moves on to running the tests. Trigger a push or the appropriate CLI command so that Projexlight runs the tests. In the logs, you can see tests being executed, their status, and whether they passed successfully. When all tests are complete, Projexlight reports the results both in the CLI and in the Docker logs. You can confirm that the tests passed and that the image or artifact was pushed successfully to your registry or target environment as configured. Step 8. Inspect generated APIs and use them for orchestration. Return to the Projexlight UI and go to the API section. At the beginning of the prototype you saw this section empty, but now you will see a list of generated APIs. Each API includes details such as the request structure, expected response, and the variables you need to pass. This information is extremely useful for building higher-level orchestration flows and end-to-end functional tests. For example, you can define a workflow where you first call a login API, capture the token, then pass it into a registration API, and finally call a booking API such as book ride. Using Projexlight's orchestration and Docker-based execution, these workflows can be run repeatedly as function tests. Step 9. Continue tasks automatically and accelerate delivery. After the initial commit and test run, you can send another CLI command using the same generation plan file. In that command, you can ask Projexlight to update completion status and continue with the remaining tasks. The CLI will then move from task 0 to task 1, task 2, task 3, and so on, automatically completing them according to the plan. You can watch in the left-hand side of your IDE or in the Projexlight UI as tasks move from pending to completed. If you want faster progress on a large project, instead of running one task at a time, you can instruct Projexlight to continue and complete the next 5 tasks. It will then parallelize or batch these tasks where appropriate and move through them much more quickly. As it progresses, Projexlight keeps generating code, adding test data, and updating the status in the generation plan, so you always know what has been completed and what remains. Step 10. Scale out with sprints and multiple developers. Once you are happy with your prototype and want to move into ongoing development, you can switch from prototype mode to sprint-based generation. In Projexlight, there are 2 main options: prototype mode for the initial build and sprint mode for ongoing development. After the prototype is ready, you can create sprints, add more features, and assign tasks to multiple developers. Each developer can work on a separate branch. They can download the package for the tasks assigned to them, run the CLI in their branch, generate the code, and then push their changes. MCP will validate their commits using the same coding standards and automated tests, keeping the codebase clean as the team grows. Step 11. Review the result and next steps. At this point, you have seen how Projexlight can take a simple description and turn it into epics, features, scenarios, tasks, and database tables. Export a CLI package that you can run locally in VS Code. Spin up a full Docker-based development and test environment automatically. Generate clean code without spaghetti, enforce your coding standards, and run automated API tests with real test data. Continue tasks automatically and support sprint-based development for multiple developers. The same flow will also generate UI components as related UI tasks are completed, but those details are beyond the scope of this particular video. You can experiment with UI tasks on your own and extend this prototype into a full application. Thank you very much for watching.